All right, let's just jump into things here. Just to reiterate my bio there, Scott Piper, I'm Dabadoo on Twitter. Those are zeros, not O's. It's hex. That's the cool thing to do in InfoSec. So as you said, I've been in this business for about a decade now. Developed all sorts of different tools, from something similar to CuckooBox, something similar to Facebook's OS Query or Manion's Response. Similar to those, not those products themselves, but I guess competitors that have been more private. And then recently I founded a company called SummitRoute, and we're developing an endpoint security product. What that means is that an aspect of that product is to do application whitelisting. And so Authenticode is one of the technologies that's used in application whitelisting. So I'm just going to give you guys an overview of what Authenticode is, how to use it, and some of the details about it. So Authenticode, if you right-click on a file on Windows and select Properties, for a file that is signed, you'll see that Digital Signatures tab. So in this example here, this is Adobe Reader that I looked at, and so you can see that it's signed by Adobe Systems there. Authenticode is a standard that is used. It has a lot of standards that it's built on. So for example, PKSC CS number 7, and a bunch of other, I guess, just acronyms. And I'll go through some of those and how they're used later. And then, so it works on, most people are most familiar with it working on executable files, DLLs, sys files. When you install an MSI file, those can also be signed, but a lot of other things can be signed as well. So it was originally created for ActiveX files, actually. Java applets can be signed with it, and even PowerShell scripts, which are just text files, can be signed with it. So it can really sign anything. If you want to try and ensure the integrity and be able to verify where a file came from, Authenticode is the solution for that. And so I should also state, just Authenticode in general, you can think of it a lot like SSL. Basically, all the same technologies, including X509 and PKCS number 7 there, all those different things are within SSL. You confirm that a file came from a place because it's been signed by a certificate that was itself signed by a certificate authority, or there's some type of chain of trust that goes up to that certificate authority. So anything that you know about SSL is going to work a lot in the same ways for Authenticode. So why would you code sign files? In some cases you have to. So if you want to run a Windows 64-bit driver on Vista or above, you're going to have to sign it. Additionally, it's going to avoid some errors. So on Internet Explorer, when you try and download a file that has not been code signed, and you're one of the first people to download that file, you're going to end up getting this error message there. And so if you're a business and you're trying to provide some software to people, some people might not want to click on that, and that might hurt your revenue ultimately. And it's really just a way to establish trust in a lot of different ways. So as a developer, these are the reasons that you want to do it. And I'll discuss later on why an administrator, you would want people to do this. And then additionally, it gives you access to Windows error reports. So if you are a software company and your software unfortunately has a bug in it and crashes on systems, and those systems end up sending Windows error reports back to Microsoft.com, if you have informed Microsoft that this certificate that file was signed with belongs to you, you can actually get access to those error reports. And so they're anonymized and everything, but it will basically help you as a software developer be able to identify where bugs exist in your product out there in the wild. So the other reason, of course, is all the cool kids are doing it. You want to be popular, and all the popular kids are doing it. So here at the top, we have a list of certificate authorities, and below those are some of the different products that have been signed with those certificates, or that there's a chain of trust that goes up to those certificate authorities. So there on the left, you have Google Chrome and Merck, the IRC client. They're all chain up to Thought. Microsoft, of course, has Internet Explorer and Office below it, and there's a variety of other applications. A lot of popular applications are all signed. And one of the important takeaways from this is not only are a lot of popular applications signed, but they're signed all across the board with different certificate authorities. So it doesn't really matter which certificate authority you sign your files with. Much like SSL, you oftentimes don't know or don't care who the certificate authority is that has granted that SSL certificate. Same concept applies to Authenticode. So a quick history of this. Authenticode is actually almost 2 decades old now. Starting in April 1996, Microsoft submitted basically a request for proposals to the W3C, an international standards body. And then shortly after that, it announced that it had Authenticode, and it had a partnership with VeriSign, who was one of the original certificate authorities. It worked on Windows NT and Windows 95. This is my understanding. I haven't actually tested on Windows 95 in any way. This is just trying to look through old Usenet postings and stuff to try and understand a lot of the history behind things. And so the reason it came out was actually for Internet Explorer version 3.0, and that was for ActiveX components. So ActiveX components are basically DLLs that you used to download and run on your computer that various sites would provide. And people realized, hey, maybe we should associate some type of trust with these things in some way, so people aren't just randomly downloading them from random sites. And so Authenticode was put in place in order to establish that trust, to say, yes, this random DLL you're downloading on the internet and are going to be running on your system actually came from your bank or whoever it happened to be. So when it first came out, there were 20 companies that were initially signing their code. Of those 20 companies, I only recognized 2 of them, Autodesk and Citrix. It seems all 18 others all have passed away in some manner, or been bought or whatever it happens to be. But so it initially came out and there were people doing it. So it wasn't, just they came out with this technology and no one happened to be using it. It was actually used. So about a year later, I believe it was on March 3rd, I had a lot of trouble trying to track this down, but Authenticode 2.0 was released. And the reason they needed to do this was because it added timestamping. And I'll get into why this is necessary, but basically one of their original root certificates was set to expire basically 2 months after Authenticode 2.0 came out. And without getting Authenticode 2.0 out there and without getting timestamping in place, all of the files that had been signed previously with a chain of trust up to that certificate that was going to expire, it basically was not, it was voided. It didn't understand how to establish that chain of trust anymore, because it said, their certificate is expired, and so I can't trust that this is actually from a trusted certificate anymore. So in 1997 also, this guy Peter Gutman, who's pretty famous Crippy, I believe he's New Zealander, maybe Australian, but he reverse engineered the format. So although Authenticode came out and it kind of explained, and there was some documentation to specify how it should be used and everything, the actual file format for it wasn't understood. And so Peter Gutman's paper is very often referenced. And Windows 2000 came out in 2000, and that came with software restriction policies. And so that was really kind of the first, technology that you could actually use with Authenticode. And so what that does is it actually allows you to do application whitelisting. So beginning with Windows 2000, it's still in Windows products, you can implement application whitelisting. It is a pain to use, though, and I'll get into why you probably don't actually want to use software restriction policies unless you have a very static environment. So maybe you have a point of sales terminal or something like that you're never touching. And then 2006, Vista 64-bit came out and required drivers to be signed. And that was really the first time when people were like, oh, I actually need to do this. So before it was always like, oh, all the cool kids are doing it, so maybe I should do it, but I don't really have a reason to. And then all of a sudden it was like, oh, if I want my code to run on Vista, I actually have to do this for people that were writing drivers. And so it still has not, been enforced that everyone has to do this, because userland code, so your normal code that you're running, doesn't have to be signed. But that was kind of the first requirement for it. And then in 2008, Microsoft actually documented it, so you didn't have to look at Peter Gutman's reverse engineering solution. You could actually see a real specification for the file format. So the best practices for code signing would be that you have an isolated system that's not connected to the internet, and you compile, you sign there, and then on an internet-connected system, you do your timestamping. Timestamping has to call out to a timestamp server somewhere on the internet, and so that's why that has to be an internet-connected system. And then you deploy it. I understand most people aren't going to want to do all their dev work on an isolated box. I have done that before. It is a pain. So most people will end up doing their dev work on a box that is connected to the internet, but you still want to do that code signing on an isolated system. And the reason for that is because your code signing signature is, that's really establishing the trust that you have. So if your dev box gets compromised, at least your code signing signature has not been compromised as well, which is why you'd want to have that on the isolated system. So another thing that a lot of people do is they will just sign it. And so for GitHub and Slack's Windows client, so Slack's client actually hasn't come out for Windows yet, but they have a beta product that you can look at. But anyways, I don't know if they're actually signing it on an isolated system, but they are definitely not timestamping it. And you want to timestamp it, and the reason why is because, I'll show this in a moment, but basically in order to ensure that your file has not been signed with a certificate that has been revoked or has been expired, you have to timestamp it. So the other thing that people will do, and this is probably the most common practice, is just all in the same box. Just compile, sign, timestamp, and deploy it. And the reason you don't want to do that is just because, again, your signature is something you really don't want to get, or your signing certificate is something you really don't want to get compromised. And then probably the even more common practice is you don't even sign it or timestamp it or anything at all. You just deploy it and no one knows where your files came from. So PuTTY is a very popular application that is not signed. So checking that timestamp. So just an explanation of how that's done. So imagine if today you got a certificate that was valid for 1 year and you signed a file. If you have not timestamped it, then after basically the end of the year, after your certificate has expired, that file is no longer going to be valid, or that certificate can no longer be checked properly. So that's why you want to do that timestamping. So if you're a software developer and you figure, all right, I'm sold, I want to start timestamping. So prices, they can range from free for open source projects. A lot of places you'll see online is about $185 or something like that. VeriSign sells theirs for $795 a year. So if you're the type that buys the gold Apple Watch and has just money to burn, then get VeriSign certificates for that high price. There are some reasons you might want to get their expensive certificates because VeriSign was one of the original certificate authorities. They're trusted by much older operating systems, so if you're still targeting like Windows 95 or something like that, then you're going to have to use a VeriSign certificate. But if you look around hard enough online, you can find certificates for $89 per year for just your normal userland certificates, or $165 per year for certificates that are capable of signing drivers. So that's where it's kind of the EV or not, that extended validation or not. So much like with SSL certificates, if you look at a lot of bank websites, they'll say the name of the bank and then the URL there, and that's because they have an EV certificate. So as opposed to just having a picture of the lock up there, they also have a green little banner up there and the name of the company. That's what an EEV certificate is. And for SSL, there's not a whole lot of reason to get that EV certificate other than it just makes you look cooler and more trusted and stuff like that. But for code signing, you actually have to get that EV certificate if you want to get a driver, or if you want to sign drivers. And so those prices there, that $165 a year, that's if you get a 3-year certificate, so one that's valid for 3 years. I think if you get just a 1-year certificate, it's like $224 or something like that. So that's if you go to sysdev.microsoft.com, which is also the website that you would go to if you want to get access to your Windows error reports. You follow some links in there, and then basically it'll bring you to some site. It's going to be DigiCert is where you ultimately want to go in order to pick up those cheaper certificates. So now that you have a certificate, how do you actually sign the files? So you can use Microsoft's sign tool. That's going to be the way that you'll see online most of the times to sign it. There's also an open source tool called OSSL-Signcode. The reason you'd want to use that is if you want to do your signing from a Linux system or something like that in order to code sign files that are on Windows. There's also a bunch of vendor tools. So I myself actually use DigiCert for my certificate, and so they have like a special tool that I use and run that on my isolated system. And I'm in no way I'm a spokesperson or anything for DigiCert, but they are, I guess, a local company. So if you want to support local, I guess they're Salt Lake City based. So how does this all work then? So you have your certificate, you signed a file. Well, what did it actually do when you signed a file? So here on the right I have a PE header information, and the items that are grayed out there are the items that are not going to be hashed when you hash that file. So basically when you sign a file, it creates a hash of that file, and then ends up signing that hash. And so you have to know like what you're going to be hashing in that file. So Sign tool or OSSL sign code or any other tools are going to read in your PE file, your executable, and then it's going to read everything in the PE header except for the checksum and the certificate table entry. The certificate table entry is basically a pointer to where in that file that certificate exists. Then it's going to sort and hash the different PE sections, and then hash anything else that's remaining in there, and that's going to be your hash of the file that's used. So certificate table looks very much like just SSL cert data. There's really almost no difference between that information. It is ASN1 encoded, and what that means, ASN1 is basically just a binary file format. So if you know XML or JSON, those are text-based file formats. ASN1 is just a binary file format. So I guess like Google protocol buffers would be something similar to that. And so now you're described. ASN1 format will say, okay, this byte means that something that follows it is going to be a bit, or it's going to be a string, or it's going to be an integer. And so it just lays things out like that. But then you need PKCS number 7 in order to describe what is going to be in that file. So it's basically like a schema for XML. It's just going to say, okay, the first thing that's in there is going to be the version of the certificate. And the next thing that's in there is going to be the subject name for the certificate, and just kind of describes what each of those things are. So it's all standards-based, all that information. It's there's a little bit of Microsoft quirkiness to it, but for the most part, it's all pretty standard. And then you want to check that chain of trust. So if you want to validate that a file came from somewhere, first you want to ensure that the signature is valid. So hash the file in the same way, compare the signature that you get with the one that is provided by the file. Ensure the chain of trust is valid. So basically each of the certificates are going to be signed one after another up until the certificate authority. Ultimately, ensure the certificate authority is trusted. So these all chain up to somewhere. So make sure it's not a self-signed certificate that you don't trust. And then you can also include in the certificates what that certificate should be used for. So certificates can be used purely for SSL or purely for code signing. There's not a lot of cases where that's going to be mixed. So because of that, you want to ensure that the code signing certificate that you're looking at is actually for code signing and is not an SSL certificate or anything else. So if you actually want to play around and look at some certificate information about your box, if you run certmanager.msc, you'll be able to see information about the root certificates that you have on your system. And you can double click on some of those there, and you can see information about what's in that certificate. So in there, you can see at the very bottom that I've highlighted, it's showing the key usage information. Unfortunately, for certificate authorities, it's not super useful because the certificate authority might specify only certain key usage information, but it can actually be used for everything. So it's hard to be able to tell on a system, given that you have like maybe 100 certificate authorities or a couple dozen or something like that, which of these are for SSL, which of these for code signing. You can't really tell, unfortunately. And then there's catalog files is another important thing to understand. So this is something a lot of people run into when they first try and look at files that are code signed. So they'll take calc.exe and they go to look at the who's it signed by just to make sure that they have a good understanding of Authenticode and be able to whitelist. And they look at it, and within its properties, there's no digital signatures tab. And they're like, "What? Isn't this signed? Like, didn't this come from Microsoft? Have I been hacked? Is this malware? Like, I don't understand." And the reason for that is because it is signed, but that signature is actually in a catalog file, which is a separate file. And so Windows, for whatever reason, doesn't check those catalog files when it displays the properties view here. But if you use various tools, for example, here I'm using SigCheck, which is it comes with Visual Studio. You can use, or is that? That's one of the sysinternals tools, SigCheck is. Using SigCheck, it'll actually check the catalog file for you. So that'll help you be able to verify where it is, that it is actually signed, and it'll also show you sorry, SIGCheck does not show you what catalog it's in, but sign tool will show you what catalog file it's in. So looking at that file, you can then look at where the catalog file is. And so here in Windows Explorer, I'm looking at all the different catalog files that I have on my system, and I can see there I think that says 3,000 different catalog files that exist there. So then looking at one of those catalog files, so this is the catalog file that was used for calc.exe, I can see that there are almost 5,000 different files that have a signature in there, so those are what those different tag entries are. And so those thumbprints are basically the SHA-256 hash of those files there. And so if you trust that, that catalog file, then you should trust that file. So what I've looked at here is if you go to, I don't know how to pronounce it, lapo.it. You go to that site, it's just a web app up there that you can drag and drop a catalog file to or any type of certificate to, and it'll actually do the ASN1 parsing there. So you can see on the left some of the information that's included in the parse. So it should show you there's some sequences, there's going to be some integers, there's going to be like an object ID. Object ID is specifying what information is going to come next in that next object within the sequence. And then there on the right, you just have a hex dump of that information. And this is a pretty cool web app tool to just be able to understand the ASN1 format better. So revocation. So if you do lose your certificate, or it gets, I guess if your system gets hacked or something like that, and you haven't put it on an isolated system, you're going to have to do certificate revocation in the same way that with SSL certificates and things like Heartbleed and stuff, you had to do some revoking there. So again, it's very similar concept. And so within the certificates, there's going to be a link to a CRL file that's going to be basically a cab file. So same format that we saw before, except instead of the cab file containing certificates that you should trust, it's containing a list of hashes of certificates that you should not trust. And so just to give you an understanding of some of those things, it's updated about twice per month. And each of those certificate authorities in those CRL files, they end up revoking about 1,000 certificates per year, and they rarely give a reason. So with SSL certificates, you can give a reason like it's been compromised, or I lost it, or something like that, but they never give any reasons for it. So just miscellaneous information for you here. Adobe, they sell their products, for example, Adobe Reader, they sign it with a different certificate per product and per version. So, for example, Adobe Reader version 11 is actually signed with a certificate that's specific to Adobe Reader version 11. So they had a different certificate for Adobe Reader version 10. And if they are going to sign a different product, they have a different certificate. So that's just kind of an interesting use case. That's kind of rare. Most of the times people just use the same certificate for all of the products at their company. And from what I saw, I looked kind of in the history of things, and Adobe Reader version 5 was first signed back in 2001. So just to give you guys an understanding that a lot of files are signed today. So if you are a developer and you're developing different products, you may want to run into the awkward situation in which you want to modify a file after you have code signed it, which is exactly what you should not be capable of doing. And so the reason that you would want to do this is Dropbox and GoToMeeting do this technique, which is you log into Dropbox, for example, and you typed in your credentials in there, and then you download the installer, and most of the times what should happen is you download the installer, you run that installer, and then you have to retype in your credentials in order to be able to authenticate your system again. What Dropbox has done, though, GoToMeeting, is they have actually included in that installer you downloaded some of your authentication information so that you can just download the installer, run it, and you're already authenticated. No need to retype in any of your information. So that's kind of a nice little usability benefit there. For myself, I needed to use it because my product basically, an administrator is going to want to download it and then run it across all of their systems, and you want all the systems to be able to authenticate up to a cloud server, and you don't want to have to retype in your credentials into all of your potentially thousands of systems that you've installed my product on. And so the way that they accomplish this is if we look on the left here is, I believe this was like the Adobe Reader installer, and then on the right here, I believe was the Dropbox installer. And so here I have highlighted in the unauthenticated attributes a section there, which is the authentication information for the Dropbox server. And so what's in there also is a counter-signing signature, which is the timestamping signature. So if you remember, sorry, go back to this. If you remember, I talked about previously, you want to sign on one box and then timestamp on another box. And so if you already signed the file and then you timestamp it, timestamping is going to be modifying that file in some way. And so that's what it's doing, is it's adding information to that unauthenticated attributes there. And so that's the trick, is adding information to the authenticated attributes in order to add in whatever additional configuration information you want to add to your file. So there were some other tricks that you could do. You could add information to the very end of the certificate table there, but someone was doing something dumb. I believe it was Google that was doing this for their Chrome installer, and what they were doing is basically they just give you a bootstrap installer that's only a few K or something like that, a few hundred K, and then that will go ahead and download an external installer of a few megs in order to install the remainder of the application. Unfortunately, what they were doing is in that in the end of that certificate table there, they just slapped in a URL. And so basically you download your Chrome installer or bootstrapper. And so again, I believe this was Chrome. I apologize if it was not them, but that's my understanding of the situation. You download this bootstrap installer and you verify its integrity. It says that it's from Google, and then it would download this additional installer when you went and ran it. Unfortunately, someone figured this out, that was what was happening, so that they changed that URL that it was downloading to be, bad.exe from evil.com. And so you download your Chrome installer and check it, and it looks fine and everything, and then you run it, and it downloads bad.exe instead and runs that. And so that broke the whole concept of being able to verify the integrity of the files. So Microsoft decided to, give them a slap on the wrist and not allow this anymore. They still do allow the other trick, so eventually someone's probably going to do something dumb, and Microsoft's going to block that from happening as well, but for now it's possible. So if you do decide to do this trick, be very careful what you put in that area. Do not just put a URL in there to download. You should probably in some way verify the integrity of the data that is in there, so you might want to code sign or do some other type of signature check on the data that you put in there with a different certificate, some type of quirky thing, or just don't put anything too valuable in there. So in order to help you guys be able to accomplish that, and because I had to do it myself, so I modified OSSL sign code and added in capabilities in order to do that. So that's the GitHub account for Summit Route. You can download that fork there. It is in the official branch as well of OSSL sign code now, but they haven't made an actual release of it yet. So I have some binaries that you can run if you want to, and they are code signed by Summit Route and everything, so you should be able to trust their integrity. So if you actually want to use Authenticode in order to verify the integrities of files, you'll ultimately do something called application whitelisting. And so application whitelisting is an old concept, but it's just not used as often. So application blacklisting is what antivirus does primarily. So they also include some application whitelisting as well. But primarily antivirus, the concept behind it is you have a whole bunch of patterns that you want to look for in a file, or hashes of files that you don't trust. And so you say, these are all the known bads, don't allow any of these to run. Application whitelisting is the opposite of that. It says, these are all the known goods, don't allow anything that's not on my list to run. So if you want to do this, you can use software restriction policies. So these have been around since Windows 2000, so it's been around forever. You have it on your system now probably, but the problem is it's very hard to manage. There's no ability to import or export. You have to use their UI for things. There's no audit mode, so you can't say, here's a list of rules I want to use, generate an alert if I ever run anything that doesn't use these rules. And so the problem with that is, if you don't have that audit mode, that means you either turn all of your application whitelisting on or it's off completely. So what that means is, if you generate an application whitelisting policy that has a list of trusted files and you forgot an important file in there and then you try and run it, it's going to block it from running. So people can potentially end up bricking their boxes by not including the right files there. And then NSA, they advocate using application whitelisting. The Australian DSD, I believe it is, which is their version of the NSA, they have like a list of top 20 things that you should do to secure your environments, and number 1 on there is to do application whitelisting. It is like very easy way to remove a lot of threats that exist out there. And so the NSA has just a document describing how to use software restriction policies. So software restriction policies is kind of a pain to use, so there's also built into Windows a thing called App Locker. Unfortunately, it's only built into the enterprise and server versions of recent versions of Windows. And again, it suffers from some similar usability issues, so a lot of people don't end up using it because, again, it is kind of painful to use. Or they don't set very strong rules in there, so maybe they whitelist a path as opposed to whitelisting a certain certificate. There are some open source tools that you can also use, but these just scan your systems periodically. So Tripwire and SysCheck from BSides.SLC. What these will do is basically you can have some type of job that every night it'll just scan through all of your files, do hashes of all of them, and then ensure that no new files exist or nothing was changed or something like that. So it's not really protection as so much it is just a detection to see if you had been hacked at some point during the day or during the week or whenever you schedule that job for. So if you do want to do application whitelisting, how much pain is involved in this? So this is just a sample system. This is one of my dev boxes, actually. Looking for any files that have a PE header on it, so just anything that starts with MZ at the very beginning of it. I had about 23 or 24,000 different files on my system. And of those, only 8% were not signed. And a lot of those existed within C Windows Assembly and C Windows SSX, which is basically used for .NET, where it is automatically generating some files in there. And so those were not code signed. Additionally, Cygwin is not code signed, so if you are using various Git clients on Windows, chances are they're using different Cygwin files or just other open source files that aren't going to be signed on there. And so on my system, there were 8 different Microsoft certificates, and these accounted for 89% of the files on my system, and there were about 36 certs total. So I would just have to have rules set up for 36 certificates, and then a couple other rules in there, or a few hundred rules for different hashes that I want to trust as well. And that would be able to lock down my system so that nothing new could run on my system. So why would you want to do application whitelisting? What are the different threats that it's going to be stopping there? So kind of the most obvious threat is just if you're tricking the user into downloading and running something, it's going to block that. Additionally, DLL hijacking, or if you plug a USB into a computer and it tries to use autoruns tricks or Stuxnet's .link vulnerability, if any of those victims had have used application whitelisting, they would have not have been, exploited or compromised. And then a lot of malware campaigns are blocked. So application whitelisting is not directly trying to defeat things that are going to be using memory corruption exploits, so different buffer overflows, or things of that nature where you're getting code to execute in memory, because once you can execute in memory, chances are you may be able to stop one of these application whitelisting solutions from running. So this is really just trying to stop legitimate ways that Microsoft runs tools or runs processes from being able to run. And then additionally, it'll help stop different man-in-the-middle attacks. So if you download PuTTY, you're downloading it over HTTP. It is not signed. You have no way to verify the integrity of that file other than checking it on VirusTotal or trying to verify that this is a known hash of the file or something like that. And then additionally, a lot of auto updates, they just occur over HTTP as well. So that's it. So I'm a pretty fast talker. There's lunch coming up and everything. But if you guys have any questions, feel free to ask. Or if there's a few moments of awkward silence, then just start clapping. Yeah. Mm-hmm. Yeah, so this is a way of verifying the integrity of all those files. If this is application that you wrote, most of the times people would just end up signing the initial installer, and so then anything that's contained within that installer should also be trusted. The best course of action is to sign all of those files, but that's usually what most people end up doing. And then as far as, if you installed it somewhere and then you want to verify that those files haven't been changed or something like that, I mean, you could use this, but this is probably overkill for that. I'm not sure what a better solution would be. I have run into situations where users have done weird things like that, where they decide they're smarter than the developers and they figure they'll just replace a DLL or something like that, and you're just like, how? That's a horrible idea. But yeah, I'm not sure if this would be the best solution for that, really. I would say there are some of those open source certificates out there, so you could try and start just signing things with those. The easiest way, though, is just generate your own self-signed certificate, and then you can add that self-signed certificate as a certificate authority on your own system, on your own test box, and just play around with things like that. That's going to be your easiest way. Using the open source certificates will allow you to share whatever executables you've generated with a friend, and it'll be able to work on their system, and they'll be able to verify the integrity. But for the most part, everyone just uses self-signed certificates. That's what I use in testing myself also, is I just generate a self-signed certificate, have that certificate authority, trust it on my test boxes, and then deploy to those systems. And then once I wanted to really actually deploy my code, then I'd go ahead and do the painful process of transferring it to an isolated system and code signing it and everything like that. But just for testing and development purposes, it's obviously a lot faster to do everything on your own system there. Any other questions? All right, thank you.